Hi, welcome to video 7.8 on solving systems of equations with elimination. So when we're doing elimination, I'll give you a little example. Let's say we had something like 2x plus 5y equals 7, and we had 2x minus 3y equals 8. So if we had something like this, we would add these together. And because these are opposites, they would eliminate. We would no longer have an x, we would just have a y. So 5y plus negative 3y is 2y equals 15. And now that we have an equation that only has a y in it, then we could solve. So we would have y equals 7.5. And then we could substitute the y back into one of our original equations in order to solve for the x. So sometimes they're set up like this when they're already ready for elimination. Sometimes they're not. When we have something that looks like this, it's not really set up for elimination already, but we can easily make it ready for elimination. So this problem asks us that to solve it two different ways, one by eliminating the x and one by eliminating the y. So we're going to look here first. Here's my x. And I want my x's to be the same. So you can think about it kind of like common denominators. Like if I had a 1/2 and a 1/4, and I wanted to add them together. Okay, so on this one, we're going to eliminate the x. When we had 1/2 and 1/4, if we wanted to make them the same, we would use their greatest common factor, which would be 4. So we would multiply our 2 by 2. And we're going to do the same thing here. So if I multiply this whole equation by 2, that's going to give us opposites. So this one stays the same, 4x plus 5y equals 12. And this one is negative 4x plus 2y equals 16. And then we're going to add them together. So 4x plus negative 4x is 0, and so our x is eliminated. 5y plus 2y is 7y equals 12 plus 16 is 28. Divide both sides by 7, and we get y equals 4. Then we're going to substitute our y back into one of our original equations, and we can do whichever one we want, whichever one looks easier. I'm going to choose this one. So 2x plus 4 equals 8, minus 4 on both sides, and we end up with x equals negative 2. So our coordinate pair is negative 2, 4. So that's one way to solve the system. The second way, we can eliminate the y here. So this is already 5y. I'm going to multiply this one by negative 5 so that they become opposites. So 4x plus 5y equals 12. And then 10x minus 5y equals negative 40. So 14x, those eliminate, and then that's negative 28, and we have x equals negative 2. And if I put it into whichever equation I want, I'll pick a different equation this time. So 4 times negative 2 plus 5y equals 12, and add 8 to both sides. 5y equals 20, so y equals 4. So I still end up with my ordered pair, negative 2, 4. It doesn't matter which way you solve it. You can pick whichever way seems easiest to you. Okay, so if we want to check our equation, we can do it by just showing that these points are a solution to our original equations. So I'm going to rewrite my original equation, but instead of x, I'm going to put in negative 2, and instead of y, I'm going to put in 4. And so this is negative 8 plus 20, and that checks out because 12 does equal 12. And then we would do the same thing with our second equation. So we've got negative 2 times negative 2 plus 4 equals 8. So that's going to be 4 plus 4, which also checks out. So this isn't something that you would do all the time, but when it's really important not to make a mistake, then you would go back and check your work like this. Okay, I want you guys to try exercise 2 by yourself, and then come back and check your answer. So pause the video and give it a try. Okay, here's your answer for exercise 2. So we came up with the ordered pair 4, 10 for this one. All right, so there are some other things we can do with systems of equations. One of them is something that we already know how to do. It's just another method of the same thing. So when we have a y equals mx plus b form and we have two ordered pairs, we usually use our slope formula to find our slope and then plug it in for m, put in an x and y, and then solve for b, which is fine. That works great. But another way to do it is to use our y equals mx plus b formula and put our points in there to make a system of equations. So for example, on the first one, instead of y, I'm going to put negative 11 equals, and then m, we don't know what m is yet, but we do know that x in this case is negative 2. So we've got negative 2m plus b, and then we're going to do the same thing with our second point. So we've got 14 equals 3x plus b. And now we have a system of equations that we can solve in order to find our that should be an m, to find our m and our b. So I am going to multiply this whole thing by negative 1 so that I have a negative b and a positive b, and those will eliminate. So that becomes 11 equals 2m minus b, and then this one, I'm not doing anything to it, so it's just still 3m plus b. And then that is 25 equals 5m. And so I have 5 equals m. If I put it into either one of my equations, I'm going to put it into this one. 14 equals 3 times 5 plus b. So 15 plus something equals 14. That something is going to be negative 1. So b equals negative 1. So my y equals mx plus b is y equals 5x minus 1. Okay, so on this one, same thing, except our ordered pairs are given in table form. So this is like negative 2, 3. This is like 2, 5. So you can find your m and your b to write your y equals mx plus b format, and you can do it the system of equations way, or you can do it the finding the slope and plugging it in and finding the y-intercept way, whichever you want. So pause the video and give it a try. Okay, your answer for that one should be y equals 1/2 x plus 4. Okay, last one. Now we're going to look at something where we have a problem we need to solve. We're not given the system, we have to create the system. So whenever you're creating a system of equations, the first thing you're going to do is figure out what your unknowns are and then give them variables. So in this one, we've got a sum of a larger number and twice the smaller number is equal to 13. Their positive differences is equal to 8. What are the two numbers? So that means that the two things we don't know is our larger number and our smaller number. So it says the sum of the larger and twice the smaller is equal to 13, and then twice their positive differences, meaning that we're taking the larger number minus the smaller number, is equal to 8. So that's going to be our system of equations. And then this one is nicely set up for elimination, because if I distribute that 2 to that already negative y, then I have 2y and negative 2y, which gives me opposites. So these guys eliminate, and I have 3x equals 21. So my larger number is going to be 7, and if I know that 2 times whatever here is going to give me 8, so that means that 7 minus something is going to give me 4, so that something has to be 3. And you could substitute it into either one of those to find your 3. That's just the way I chose to think about it. Okay, make sure you write down any questions that you have, and we'll talk about them in class.